Hey, Sarah, I stepped out for a second to go grab something from the printer. So I don't know how long you've been here. I apologize if
Oh,
it's a little bit.
no, that's fine. Just a minute. Can I actually invite a Chem 1 student from a different professor's class? He, yeah, okay. Because he was like, oh, you have a problem solving session. I would benefit from that. Okay, let me see if I can figure out how to invite. Oh, okay. I'm going to copy this invite link and text him and we'll see if he joins.
Sure. All right. And what I'm going to do is I was sort of in when I went to the printers, I was like preparing a little bit for like nobody showing up. And then I was not going to just sit here and like record nothing forever. But what I would do is I was just going to put together a few videos just of me doing some more problems, but we'll do those problems, but now with you and then this other student if they show up. What I am going to do is I'm going to kind of do a few more basic kinds of problems that are similar to kind of what you might see on quiz and so forth. And then we might, I'm going to stretch you. I'm going to give you a couple of more challenging problems. That's sort of the intent of what we have here, is not just kind of doing the little mini skill things, but see if we can kind of stretch you. So let me get my iPad and stuff set up, and then I'll get you started with that first problem.
Okay, I have to leave at like 12:50. I have an appointment.
Okay,
So.
that's fine. Until I get my iPad set up here, Sarah, what I might do is I'm just going to put this first problem in the chat.
Okay.
That way you can see that the text for it and then start working on that one. So let me find it here.
I got the right answer for a practice problem, but my equation looked a little bit different. Basically, my first half was I just solved for the moles. And then once I got the moles, then I went in and did the finding the molarity. So it didn't look identical to yours, but it had all the same pieces,
and that's fine. I mean, and I want to encourage people that, especially if they've learned how to do something because they've taken a chemistry class before, you never have to do it the way I do it. But if you don't get the right answer and I can't follow your work, it's harder for me to give partial credit. So especially if it's somebody who's just learning, I encourage them to kind of try to work through it.
Yeah, I mean, it didn't look, like I said, it didn't look too different from yours. And I definitely did get the right answer. I just, I guess for me, it's just like, it's easier for me to just find the moles. And then once I have the moles to go where I need to go from there.
Got it. All right, so here's the first problem. So it's 26.25 milliliters of 0.1850 molar sodium hydroxide solution. If that reacts with 25 milliliters of H2SO4, what is the molarity of the acid solution? So start trying to work on that. I will get my iPad set up momentarily and we'll go through the solution. The answer, oh, actually, I don't have the answer written up there. Hang on 1 second. I'll put the answer in the chat as soon as I find it here. And that way you can let me know if you're done or ready.
Okay, probably not, because I'm not super fast at this.
That's
like
fine.
I said, I get the right answer, but I don't get there fast.
You're good. All right. All right, let me get my iPad connected here and then we can go over that problem. So ready, and I'm assuming so ready, you did not get that answer. Did you get close?
I did get close. Well, I kind of got, I realized I didn't balance it first. I think I structured my stoichiometry correctly, but I forgot to put the 2 subscript when I put the sodium
Got
sulfate
it.
together. So
Got
then
it.
I was like, why did I get it wrong? And then I was like, oh, because I forgot to put the 2 subscript, and so I didn't balance it right.
Got it. Got it. Got it. All right. All right.
So what I have is I got, I did my 26.25 milliliters times 1 liter over 1,000 milliliters
Mhm.
times my moles of 0.1850 moles over 1 liter times my molar ratio, which is where I went wrong,
Mhm.
of my sodium hydroxide on the bottom and my that's sulfuric acid.
Correct.
Okay. That's where I went wrong. My molar ratio was wrong because,
Got it.
like I said, I forgot the subscript. But then I did from there, I would have gotten my moles. Had my moles been correct, and then I could have figured out my molarity by doing the equation of molarity equals moles over the
Mhm.
amount that I have, which is, it would be 0.025 liters.
Correct.
Okay, so I would have gotten it right, I think, if I had balanced it correctly.
Got it. So just walking through, because again, I know some people might watch this later. So, and again, I have pictures because I think sometimes pictures can help students sort of figure out what the pieces are. So we've got some sulfuric acid here and some sodium hydroxide that are going to be combined together. And that's an acid and it's a base. So we're going to generate salt and some water. So putting that into a chemical equation, we've got sulfuric acid and then sodium hydroxide. And this is the one that we talked about. We actually had a problem in class to deal with this. Sulfuric acid is what we call a diprotic strong acid. So that means it's doubly as strong. So we need twice as much sodium hydroxide in order to neutralize that. And so then we get that sodium sulfate and then water. And that part of the equation, even if you didn't have that right or balanced, you could still get the right stoichiometry with this. But remember, for your quiz that we're going to have with this unit, part of it is being able to identify the correct balanced chemical equation.
Yeah,
So,
I had 1-to-1 at first. It's 2-to-1, right? Like it's 2. Yeah. Okay. So that's where I went wrong.
Yep. So putting our walk together here, we always start our walk with information that does not have a question mark as part of it. So looking at the prompt for this, we want to know what's the molarity. So I'm not going to start there to sort of do my walk. I'm going to start here, and since I know the volume and the molarity of the sodium hydroxide solution, I can use that molarity with the provided number of milliliters here to get to moles of sodium hydroxide that I have. Oop, and my arrow is actually going in the wrong direction here. Then we can change who we're talking about using the balanced chemical equation. And this is, we've seen a couple of problems now in class like this. It's not just kind of completing the stoichiometry walk like that. We get the moles of sulfuric acid that we have here. And since the problem is asking us for a quantity that has a numerator and a denominator, part of our stoichiometry calculation here gives us the numerator. The denominator was provided for us in the problem. So going through the math here to get the number of moles of sulfuric acid we have here, that's this guy here. And then to solve this problem, we actually have to take that number of moles that's provided and then put it over the volume of sulfuric acid that's provided. And we do need to convert that into liters. From time to time, I might put that unit conversion in, but I want you guys to get comfortable doing, especially those factors of 1,000 in your head. It'll just save you a step kind of in your unit conversion problem. So we divide by 0.025 liters, and then we get an answer here. And I should make sure I have units with my answer here of 0.09713. And I think when I wrote the answer for this problem, it said 0.09715, and it may have just been when I first did this problem, I was rounding sooner than I should have. I encourage you guys, and this can be a way that you may be just a little bit off, but that's why whether it's the Blackboard quizzes that we have, you always have plus or minus 5%, which should account for rounding errors. But I encourage you, I would keep at least 4, maybe even 5 significant figures if you're having intermediate steps in your problem, and then only round your problem at the end. And looking up here, just reminding us of significant figures here. There's 4 significant figures in all of our values there. So we're going to have 4 significant digits in our answer. Okay. So questions, Sarah? I think you said that you pretty much had all of those parts.
I did. And once I corrected my ratio, I went through and I got the right answer using, my equation was structured correctly. That was the only place where I went wrong. So that was just a dumb mistake on my part.
Got it. All right. So I'm going to get another problem here. And I'm going to put in the chat. Give me about 1 minute here because I have to find the numbers for this. I had a problem that I was planning on doing and I can't find them right now. It has to do with kind of Tums neutralizing stomach acid. So give me just a second here and I'm going to pause here and I'm going to go find that. All right, Sarah, I'm going to put this problem in the chat again, and then actually make sure to put it. Everyone. It says a Tums antacid tablet contains 1.25 grams of sodium carbonate, which is used to neutralize stomach acid. And actually, I guess I don't have it written there. Stomach acid is hydrochloric acid. So let me fix this prompt here. Use stomach acid, HCl. If there is 34 milliliters of stomach acid that is perfectly neutralized by this tablet, what was the molarity of the stomach acid?
Okay. Can you hear me?
Yes, I can.
Hey, I'm a little stuck on this one going from like grams to moles, molarity. Can you walk me through this? And then I gotta head to my
Yep.
appointment.
Yep.
Okay.
So I'm going to ask you first before I show the solution. How do you convert grams to moles?
Through molecular weight.
Yes.
And so I got the molecular weight of my sodium carbonate. And then I did the molar ratio, and then I times, and then I was kind of like, where do I go from here? Like, what's the second half of my equation to get myself to like using the 34 milliliters to move forward towards my answer.
So can you see my screen that I shared?
Okay, let me just pull it up real quick. Okay.
So, and I'll let you take a look at it, but I'm going to walk through kind of from the beginning in case anybody's watching this later and kind of have some questions. So when we think about sort of what's happening here, so we've got this little, Tums tablet that has 1.25 grams of sodium carbonate. Maybe you have about 34 milliliters of stomach acid, and the chemistry that's happening is we are sort of neutralizing this stomach acid and generating sodium chloride, water, and carbon dioxide. So this is one of these. I wanted to put this one in here to highlight. Now, the right side of this equation is not actually important for you getting the right answer from a stoichiometry standpoint. But we do want to know that when we have this sodium carbonate reacting with stomach acid, if we do our double displacement, you're going to get sodium with a new partner as chloride, and then the carbonate gets a new partner with 2 H pluses. But we have to remember when we've got carbonates, they are going to make water and carbon dioxide. Okay, so for this problem, our walk is we always start from stuff that we sort of know, not where there's a question mark. So I'm going to start with the fact that I've got 1.25 grams of that sodium carbonate. I can use a molecular weight, which I have to figure out on your quizzes moving forward. I will have basically molecular weights for anything, even if you don't need it. I'm going to have molecular weights that are provided. So you won't have to worry about that, but it'll be something that you won't have to take the time to do. That'll get me to moles of sodium carbonate. Then I can convert to moles of hydrochloric acid using my balanced chemical equation. And then this problem becomes just like our last one. Since we were solving for molarity, molarity is a relationship quantity. So I need to take the moles of hydrochloric acid that I have and divide it by the volume that it's contained in. So here's the volume that it's contained in. So that's going to become my denominator. And then my stoichiometry is going to be what generates my numerator there. Put all of that math together. Say that again.
Yep. Nope. I totally see where I went wrong because I was trying to like plug in like the whole first part of my equation was right. And then I had like times the milliliters times yeah. So I totally see where I went wrong here.
That's fine. That's fine. Well, and the hope is that every time you do another problem, and I'm not speaking to you, Sarah, I'm speaking to anybody who's going to watch this video later. Anytime you do a new problem, you learn or have another aha moment of, all right, now I see what to do. So that if you get to that kind of stopping point or stumbling block in the future, you're like, now I know what to do.
Yep. Yep. It actually kind of makes me feel good because I can see easily where my mistakes are, and I can see that I am structuring the problems correctly.
And that's why, I mean, big picture, that's why I flipped my classroom, because you guys don't need, you don't need help trying to, understand definitions or things like that, or take notes on concepts. You need help working through as many problems as possible, because I want you to fail. Not that I want you to fail at all, but I want you to fail when you're learning how to do the problems so that you don't have those kind of stumbling blocks and so forth when you're taking a quiz or an exam.
Yep, that's exactly why I'm always in these things.
All right, well, very good. Well, what I'm probably going to do now, since Sarah, you're the only person who is here, I'm going to stop recording now, and then I will try to find a couple of other problems that I will just create like separate videos just to put out on just solution videos, as well as just kind of directing people to the ones that are already out there. But we did 2 problems today, so that might be sufficient just to kind of get people prepped for Monday's quiz.
Yes, thank you so much.
You're welcome. All right, we'll see ya.
Yeah.
All right, bye-bye. All right, so anybody else who's watching this video, I'm going to stop recording because there aren't any live students here right now. So what I'll do is I'll just direct you guys to other videos that are available on Blackboard, and maybe I'll put another video or 2 up. But I think there's a lot that's already out there for you to be able to watch. All right.